Hi there, welcome back to the channel and welcome to the wireless BFO project. These are the boards I got from pcbway. They came out fantastically as usual, and as I promised before, what I'll be doing after this video is I'll be making these boards available on the pcbway share section. So if you want to download them yourself, later on in the video I'll show you how you can do that. And this is what results when you wire this whole thing up. Now, just to recap, what this does is it's got a Arduino Nano. This Arduino Nano is programmed to provide a variable frequency which you adjust with this rotary encoder. The frequency is displayed on this small display, and this frequency is a frequency around the IF frequency of most shortwave radios, or AM radios. They can be tube radios, they can be transistor radios, they can be whatever. Most of them are within the 455 to 460 range, the IF frequency for those radios. And so this is producing that frequency, or rather it's instructing that little board, an AD9833 synthesizer board, to produce a sine wave of that frequency. And that signal is then sent to effectively an antenna. That antenna radiates the signal into your radio, into your IF chain, so that it can decode AM transmissions in single sideband, both upper sideband and lower sideband. Now, I'll be presenting the schematics for this circuit in the description below. There'll be a link to a Google Drive folder with schematics and the code for that. What I wanted to do is I wanted to check this thoroughly to make sure that this thing is working before I share it with you. You always have to check these things. They are prototypes after all. And I'm happy now that this thing is working perfectly. And I also promised that I would be building or designing a proper enclosure for this. And I've done that. And I'll also be sharing the 3D print files for this. And you can either print it yourself or you can actually get pcbway to produce them. They've also got the 3D printing services, which I've used before. It's up to you. I'll make these available. How you use them is up to you. But what I want to do now is just to finalize this project, because this thing is a tight fit. It's a very tight fit. I tested it on a previous prototype and I finally got this thing ready to where I believe it should work well. Now, what I'm going to be using to power this is one of these rechargeable 9-volt batteries, and this will fit in here and you'll be able to recharge it from the outside. That's the whole idea. But let's try and fit this. This should be yeah, this could be a bit tricky. You see, you've got to put this in order. I'll plug this in, plug the battery in, and everything goes in a very specific order or you won't be able to get this in. I've been through this once and it wasn't fun, but it works. I told you it would fit. It took quite a while. The reason is I've got little clamps down there to hold the display firm to the front. I didn't want to glue it. I've got the rotary encoder in place. The PC board fits into these two little protrusions over here. The battery fits perfectly down there. It has to, because you've got to have access to that charging port over there. I've still got access to the USB port on the Arduino if I need to reprogram it, which I may have to do. And then I've got the antenna over here. Now the antenna, the way this works is that it's going to radiate to a loop antenna, and this loop antenna has to be tuned, or rather this section of the circuit, the output has to be tuned to radiate or to work with the amount of turns that I've got on here. Now again, I've also 3D printed this, and I also will be making this available if you want to 3D print it yourself. It's all going to be there. It's up to you. And this has got about, I think it's 33 turns of solid core copper wire. And those 33 turns gives me about 80 microhenries. And what we need to do is to fit this in here, and I need to solder it to the output of the antenna over there. So this thing will go into this little hole over here. Somehow I've got to solder it. This is going to be fun. Yeah, this is going to be fun. I've got to somehow solder this in there so that it stays nice and firm. I can put a drop of super glue on there. And then there's a lid as well. So here's the lid. By the way, that's the old former that I had. There's the lid here. And you just I'll put a dab of glue on there. But the way this is going to operate is like this. You place this near the back of the radio, preferably close to where the IF chain is, the IF section is. And then you will tune it or switch it on. And you can tune it around the IF frequency, depending on where it is. Let's say it's 455. You can actually press this in and get bigger steps. That's 1 kilohertz steps. Press it again. I've got 10 hertz steps. Again, that's 100 hertz steps. It's probably the most practical one to tune around. And then you can, let me get this to the 100 kilohertz. You then go below 455, probably about 1.2, 1.3 kilohertz. If it's lower sideband, and you go to 456.2 or 3 if you're listening to it on the upper sideband. So you can tune it till you start hearing the voice instead of hearing all the Mickey Mouse sounds that you normally get from SSB transmissions. Once you've got that, you can then adjust the level of that signal that's going to the antenna. So that's your level control. That's just your on-off switch. Level control. You don't want this to be too strong. If it's too strong, it actually swamps your entire IF chain, literally dampens the sensitivity of the radio. So you've got to adjust this depending on how strong your signal is, or you just won't hear anything. What I'm going to do is finish putting this together, and I'll give you more details, and we'll test this out and see what it sounds like, and then you can decide whether you want to order your own boards. As I said, you can order them from the PCBway share section. I'll put a link down below. I'll also put a link to the Google Drive file that will have the Arduino sketch. It will have the schematic. It'll have the Gerber files. It'll have the 3D print files for the enclosure and for the coil, the antenna, the loop. It'll be as complete as possible, but you do have to do it yourself. And I'm not going to give a bill of materials. It's all explained in the video. I'm sure it's clear enough. All right, let me complete this, and then we can go into more details and test it. If you do decide to order these boards, you click the link down below. It's going to take you directly to the shared project for this particular project. And literally all you need to do is add to cart and proceed with the normal checkout. And just to recap, here's the full schematic so far. I'm using that 9-volt rechargeable battery just for convenience. You can use a normal one. And most of the rest is on the PC board. The OLED display comes out, the encoder comes out, and all this is explained in the previous video, which I'll link down below, where I describe the actual design of this thing. But the loop it measures approximately 80 microhenries, and that's achieved with 30 turns of 0.5 millimeter single coil wire, and that's on a 5 centimeter diameter coil former. It's an air coil, and that gives me an inductance which I have to resonate with these two capacitors in parallel. And what you want to achieve is a resonance at the frequency, or approximately near the frequency you're going to be operating at, which will be somewhere between just below 455 if it's a radio with a 455 kilohertz IF, or above 460, which is like most of the German tube radios have 460 kilohertz IF. So that's where I try to resonate it. I try to resonate it somewhere between those two, about 457. And that means that when you tune down to 455, you've still got a good response on the antenna, on the loop. And if you go up to 460 and just above, you've still got a good response there as well. That's adjusted with the oscilloscope. And because I've changed the actual loop, I've made a new loop, I'm going to check that resonance and show you on the scope as well. So you adjust the value of C7, of both if you want, to get the resonance. I was lucky. The two caps that I chose on there, both of them 100 picofarads, they resonated very, very well. So that was just my luck. But if that didn't happen, I would try slightly higher, slightly lower till I got it right. I'm going to just check the tuning on this because I did change the loop. I did create a new one. I've got the same wire on there, but I just want to make sure that it still resonates within that range that I want. I'll show the results of that on the scope right now. I have put some knobs on there. I've put a couple of labels. It says frequency, it says level and on. And I've got the loop antenna soldered in, and I've got the scope connected across the loop antenna. I'm going to switch it on now. It's at 450 kilohertz, and I can adjust that. That's in 100 kilohertz steps. Just before I show you on the scope, let me tell you what I've done. I'm going to put it in 1 kilohertz steps. Now, I did say in the previous video that I was going to limit the range from about 450 to 470. I've decided not to. I've got this thing going all the way from 400 to, there's 400, and I think it goes up to about 700 and something. And the reason I'm going to do that is that this thing is actually a useful little signal generator. If I decide that I need a signal, let's say to test RF alignments on the long wave, really, I can make it go higher. It goes to 570. I'm starting to wonder whether I shouldn't free this up and make it go all the way from, I don't know, 150 kilohertz to 1.6 megahertz, so that I can use it to RF align shortwave radios, medium wave radios, and long wave. But anyway, the point is, this thing is probably going to stay like this for now. So I'm going to show you on the scope what we've got. There's something there. It's very weak, and I'm going to put this on max. This is the level. Okay, I've got my level control on max. And I'm going to come down and watch the screen and watch that. It goes up, peaks, and then starts dropping down. Okay? Now, where are we? Let's see where it peaks. I'm watching the screen. It sort of peaks. That's just 1 kilohertz steps. Let's make it 100 hertz steps. I think that's probably where it peaks, 453.3. Now, I would have wanted it to peak a little bit higher, like 457, but and this is because of the slight change in the inductance here. This wire is longer, but I think it's going to work perfectly fine, because if I go down, let's say I'm listening to an amateur band communication on 455, depending on whether it's lower sideband or upper sideband, it'll probably be there. You see how strong the signal is? And if it's the other sideband, it'll be slightly above, about 1.2, 1.5 kilohertz above, so it'll be there. And then if it's on 460, it's actually coming down a bit, but we can still see it pretty well. It's a fairly strong signal. I would have liked to peak it 457.5. I would have liked to peak it there. But to do that, I'm going to have to replace that capacitor. I'm going to have to get very, very precise with that capacitor. And anyway, the point is, very seldom do you need to use it at peak amplitude. Oh, that's not connected properly. The ground slipped. Very seldom can I use it on peak amplitude. So regardless of what I'm getting, I'm still going to have to drop it. Let me change the scope range. I'm still going to have to drop it. So you see, you can go really low and very high. And very, very seldom do I need it to be very, very high. So I think this thing is going to work perfectly fine. Let me show you what this thing looks like now. Let me take that out. I place the lid on here, and this thing sits like that. And I switch it on, and I can adjust it. I have to put this on the radio. I'm going to put a bit of probably Velcro tape on here, and then on the radios that I use, I will check where the best position is and put the opposite piece of Velcro on various radios that I use. And if it's a radio that I haven't used before, I can just test where it's getting the best level. I'll show you on a radio now how that's going to work. And then it's a question of getting to the right frequency and adjusting the level. And Bob's your uncle. We're working. That's it. I like it. It looks neat. even if I say so myself. Time for some testing on some radios. Okay, let's try this out. First of all, how do we place this thing? Well, let me show you. I'm going to be using some blue tack just to temporarily place it on the radio. And the first thing I do is just find a station on any band. Okay. Now if I take this radio and I switch on, I'm switching it on at 460. That's the IF of this radio. I'm putting the signal on max. Now watch what happens when I move this in front of the radio. You hear that? That is beating. That's the beat frequency you're hearing. And if I move it away, let's leave it like that. If I move it away, it disappears because this thing is sending a 460 kilohertz signal to a station that's got its own carrier. So one is beating against the other. So if I put this on, I want to know where it's most influential on the radio, right? So watch this. That's louder there. That is where it's loudest. So this is annoying. I'll stick it on there. That's where it's most effective, okay? If I drop the amplitude, you can hear it. It gets lower and higher, okay? So I'm going to leave it fairly high, and now I'm going to the 40 meter band. And I'm going to leave it on there, see what I can pick up.
¿Queda 5, Julia? En cuanto a 5, Julia. Julia Fox Lima, 5-9, José Vicente, ¿cómo estás? Ahora es que está muy... La semana sale como un día. El fin de semana también sale como un disparo. La semana tarda un poquito más, pero el fin de semana tú sabes. Pablito, venga, adelante. Por favor, Chicheli Tango Fostro, ¿ok? Venga, Chicheli Tango Fostro, CCH Chicheli Víctor Sur. Pobrecito, eso funciona. Dale si voy a mandar a Piñas, pero sale más caro el transporte que el encontré ahí unos condensadores de 15 kilovoltios. Yo que sé, 100 picos faradios. Para lo mismo, 12.50 o 12.47. Si le vas a poner 150 picos faradios, pues ponle 3 de 50 o 3 de 47, que es la medida estandarizada.
That is perfectly discernible. And as you can see, I'm doing it on the 40 meter band because in this particular radio, the 40 meter band has got a band spread that spreads from 7 megahertz to 7.3, and our 40 meter band is right here between 7 and 7.1 and 7.2. Now, when I put it on the 20 meter band, which is over here, the spread at the top, it does not pick up the amateur band. I can only get it on the normal, which is down here. And by my logic, I should bring this about 1.2 below. So 458.8, say. All right. And we should be able to pick it up, but it's such a small gap where the entire band is that it's very, very difficult to pick anything up here. See that? Very difficult. Whereas if I go to that one there, put it on the spread, and I'm going to go to 1.2 above. If you can decode Morse, there you have it.
Javi. Antes escuché un amigo aquí, no sé si había algún colega. ¿Hay algún amigo por aquí? Seguro que hay más de uno. Bah, agüita, niño. Sí, señora, como tiene que ser, tiene que haber amigos. Si no hay amigos, ¿qué pasa si no hay amigos? Tienen que haber amigos por ahí. Yo te iba a decir, Pablo, que Amazon, ahí trae más que sea un saco de ellos ahí por si acaso, por si falla
Watch what
alguno.
happens when I switch it off.
Ok, venga adelante Lorenzo, y Auche Charlie Japón Zulu, con el Fauche Charlie Tango Foto, ya sabe quién está por acá, el amigo Pablo, Auche Charlie Víctor Zulu, el amigo Pepe, Auche Charlie Tango Fostro, perdón, Auche Charlie Charlie.
That works very, very well. Okay, I want to try it on this Saba Transall Deluxe. The reason is that this thing's got a very, very tight shortwave band, shortwave tuning range, but it's got fine tuning. You see over here, you can barely move the dial and it goes off the amateur band. But this thing's got something called KW or K looper, which is shortwave zoom in, if you want to call it that. It's a band spread. So I'm hoping it's going to work. So what I've done is I've set this to 7.1 megahertz. And I know that because I sent a signal from the signal generator. And I've set it so that at this end it's at 7.1 and at this end it goes all the way to 7.2. So it's still quite a spread, but I think we should be able to get it to work. Now the first thing I want to do is find out where this thing is most effective. So I'll set it to 460 and I want to wave the wand around, see where I get most interference. I think it's here. Let me try it there. See what we get. This is precarious, but it is an experiment after all. So you see, I'm not going to move that tuning at all. I'm just going to use the fine tuning control. That is all. Let's see if this works. Let me give us that 1.2 again, or thereabouts. Yeah. It's picking up something. It's picking up, I can't understand what language it is.
Gestionando, ¿ok? Venga, pues, ya te digo, un placer de tenerte por aquí, ¿eh? Voy al cambio de nativo Alex, tu canción, o al Faucho, Charlie, Wiki, para que te salude también.
Let's see if this goes up as far as 14 megs, I'm not sure. No, that's nothing happening on the 20 meter band at the moment. So that doesn't work, but it does work on the lower one, on the lower frequency, on the 40 meter band. So that's it. That's how it works. And that's it, folks. That's the end of the project. I have really enjoyed playing with this one. I've enjoyed the challenge. It works incredibly well, a lot better than I expected, which is always a nice bonus. And the question is, did I really need this? The answer is no. I've got radios that have built-in single sideband decoding, and if I want to pick up amateur band, it's very simple to do. But I really enjoy this kind of challenge. I enjoy the whole thing about this. The fact that you can add this SSB decoding without going into the radio, without even opening the radio. You don't have to mess with soldering. You don't have to damage anything. There's not even a question of it being reversible because it doesn't even go forward. It's just, I think it's elegant. That's me. My baby, I think it's elegant. I think all parents love their babies. So That's where I leave you for now, and I do hope you've enjoyed that. If you have, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon and PayPal. Links are in the description below. Once again, thanks for watching. Bye for now, and most of all, stay sane.